Okay, so in this video we're going to look at simultaneous equations when you have three equations and three unknowns. So you can see here we have three equations and we don't know x, y or z. So what we're going to do is we are going to do our normal method, our elimination method for simultaneous equations, taking the equations two at a time and eliminating one of the variables. And just like step one in our simultaneous equations with two unknowns, the first thing you want to make a decision on is what is the variable that you're going to eliminate, okay? Is it going to be the x, the y or the z? What's going to be the easiest in order to set up so that you can cancel? So if you were to take a look at the first two equations, just looking at these two, which of the x's, the y's or the z's do you think are already set up that they could be easily cancelled? And we can see here that the y's are set up quite nicely. They're not able to cancel as they are, but all I would have to do is make one of them a minus and then they would cancel. So I'm going to take those first two equations, and of course to make that into a minus y, I would need to multiply by a minus 1. Okay, so when I multiply this second equation by minus 1, I get minus 5x, minus 1 times y is minus y, and minus 1 times 2z is minus 2z. And minus 1 times 19, don't forget, of course, is minus 19. Okay, so now we are going to add the equations together, just like you would do in your normal step 2 simultaneous equations with two unknowns. 2x minus 5x is minus 3x, y minus y cancels, which is what you want. 4z minus 2z is a positive 2z, and 23 minus 19 is 4. Okay, so that is one of the equations that we will look to use in a little while. All right, that's as far as you can go with that. We're going to go back up here now, and we're going to take another set of two equations. Now, it doesn't matter which two that you take, okay, just as long as it's not the same two, but we're going to look to eliminate the same variable. So I'm going to take these two next, okay? So if I'm looking at this where I have 5x plus y plus 2z equals 19 and 3x minus 2y plus z equals 13, I have to go ahead and eliminate the same thing. So I'm looking to eliminate the y's. What would I have to do in order to set up so that the y's would cancel? Well, looking at this here, I have minus 2y down here. So ideally, I want a plus 2y up here. Okay, so that would mean I'd want to multiply this equation here now by minus 2. So that's what I'm going to do. Minus 2 times 5x is 10x, minus 2 times y is 2y, and minus 2 times 2z is 4z, and equals, and don't forget of course, 2 times 19 is 38. The bottom one stays the same, so we've got 3x minus 2y plus z is equal to 13. And we're going to add these together. So I have 10x add 3x is 13x, 2y minus 2y cancels, which is what you want, 4z plus 1z is 5z, and we have 38 plus 13 is of course 51. And that is my second equation that I'm now going to use. Okay, so now what we have in our green boxes is two equations with two unknowns. So that means we can go ahead and use our normal simultaneous equations method with these two equations with the two unknowns. So I'm going to set these up for myself as I would normally have them. So if you have minus 3x plus 2z is equal to 4 and 13x plus 5z is equal to 51, we're going to have to consider either cancelling the x's or the z's. Okay, so none of them straightforward here, but I think rather than deal with bigger numbers, I'm going to work with the z's. But it will mean I'm going to have to multiply the top by a minus 5 and the bottom by a plus 2. Okay, I just need to make sure one of them has a minus, so that's why I chose the top to be a minus, and if I make this one into 10z and this one into 10z, then that's going to be a minus 10z on the top and a plus 10z on the bottom. Okay, so let's do that. Minus 5 times minus 3x is 15x, minus 5 times 2x is minus 5 times 2z is minus 10z, and minus 5 times 4 is minus 20. 2 times 13x is 26x, 2 times 5z is a plus 10z, and 2 times 51 is 102. So now we add our equations together, and what I end up here is 15x plus 26x is 41x, minus 10z plus 10z cancels, and we have minus 20 plus 102 is 82. And now 41x is equal to 82. We'll divide both sides by 41 and you get x on its own equals, and the answer of course is 2. So x is equal to 2. So there's one of my solutions. So just as you would have done before, with your two equations, two unknowns, you will take your first result and you'll sub it back into one of the originals. So back into one of these then. So we'll take x equals 2, and I'm going to put it back into the top one, okay? Because these are larger numbers. I'm just going to go with the top one. Again, either doesn't matter. So minus 3x plus 2z is equal to 4 is the equation I'm going to take, and I'm going to sub in x is equal to 2. So instead of minus 3 times x, it's going to be minus 3 times 2 plus 2z is equal to 4. That's minus 6 plus 2z is equal to 4. And then add 6 to both sides. I get 2z is equal to 10. Divide both sides by 2, and I get z is equal to 5. So now we've got two of the unknowns. So in order to get the third and final unknown, I'm going to have to go back up here to one of my original equations, and using my two results, of course, that I have already, my x equals 2 and z equals 5, I'm going to sub these two in back into one of my original equations. So I'm going to take, again, it doesn't matter which one, but I'm going to take this last one here. So 3x minus 2y plus z equals 13. It's nice and straightforward and easy. Any of the three original, of course, will work. So 3x minus 2y plus z equals 13 is the one I've decided to take from the three original. And of course, if x is equal to 2 and z is equal to 5, I'm going to sub them in here. So instead of 3 times x, it'll be 3 times 2 minus 2y, plus instead of z, it's going to be 5 equals 13. That's 6 minus 2y plus 5 is equal to 13. Adding your numbers, of course, tidying up the left-hand side, we get 6 and 5 is 11, minus 2y is equal to 13. Take away 11 from both sides, and we end up with take away 11 from both sides, and we end up with minus 2y is equal to 2. Divide both sides by minus 2, and we end up with y is equal to minus 1. And so my three solutions are x equals 2, z equals 5, and y is equal to minus 1. Okay, so we're going to try this question. So before you try this one maybe on your own, let's first of all make a decision on which of the variables we're going to look to eliminate. That way we'll be going in the same direction, because with these kinds of questions there's lots of different routes that you can take to the answer. If you choose to eliminate the x's first or the y's or the z's, there's all different working out, but it will give you the same result at the end. So just to start off on the right track, the same track, we'll make a decision on the variables. So if we look at the x's, the y's and the z's, I think the z's are most set up for it to be an easy manipulation to cancel. So let's look to eliminate the z's from the equations. Okay, so pause the video and see how you get on with this. Right, so I'm going to look at the first two equations. The z's are set up quite nicely, but I'd like one of them to be a minus. So I'm going to multiply the second equation by a minus 1. So the first equation stays as it is, and the second equation we multiply by a minus 1. So we end up with minus 1 times 2x is minus 2x, of course, minus 1 times 3y, minus 3y, and minus 1 times z, minus z. And don't forget, minus 1 times 16 is minus 16. Just be very careful, double checking your arithmetic work, because it's not that these questions are difficult, but pupils are so likely to make little mistakes on these because they're long and tedious. So be careful. Adding your equations together, x minus 2x is minus x. Y minus 3y is minus 2y. The z's cancel, z minus z is nothing, equals 9 minus 16 is minus 7. So there is the first equation that we will use. Okay, so now I'm going to look at these two equations, and I'm going to eliminate, of course, the z again. So they're set up not too bad. If I have 2z down here, ideally what I want is a minus 2z up here. So I'm going to multiply the second line this time by minus 2. So minus 2 times 2x is minus 4x, minus 2 times 3y is minus 6y, minus 2 times z is minus 2z, equals minus 2 times 16 is minus 32. And the bottom line stays the same. And we end up adding them together. We get minus 4x plus 3x is minus x, minus 6y minus 4y is minus 10y, minus 2z plus 2z is 0 or nothing, so it's gone, which is what we want, and minus 32 and a positive 1 is minus 31. So there is my second equation that I'm now going to use. So two equations now with two unknowns. We're back to our usual method, so I'm going to rewrite the two equations out for myself. Okay, and the x's are set up quite nicely, but I just need a positive x on one of them in order for these to cancel. So I'm going to multiply the bottom line by a minus 1 in order to get a minus 1 by minus x will give me the positive x that I need. So the top line stays the same, and the bottom line is minus 1 times minus x is plus x, minus 1 times minus 10y is plus 10y, and minus 1 by minus 31 is a plus 31. So now adding them together, that's gone. Minus 2y plus 10y is 8y, minus 7 plus 31 is, of course, 24. And divide both sides by 8, we get y is equal to 3. And there's the first of our solutions. Okay, so taking our y equals 3, and we're going to sub it back into one of these two. We have y is equal to 3. I'm going to pick the top one. It's just easier numbers to deal with. Again, it doesn't matter which one you take. It's minus x minus 2y is equal to minus 7 is the equation I need to sub it into. So instead of the y, I'm subbing in 3. That gives me minus x minus 6 equals minus 7. Add 6 to both sides, and I get minus x is equal to minus 1, and therefore x is equal to 1. Okay, so there's two of my solutions. So now I've got two solutions. I need to go back up to my original and pick one of these equations to sub those two solutions into. So again, it doesn't matter which one. I'm going to go with the easiest. So I'm going to sub them into x plus y plus z equals 9. Back to one of the original. And I'm subbing in y is equal to 3 and x is equal to 1. Okay, so I end up with 1 for x plus 3 for y plus z equals 9. That's 1 plus 3 is 4 plus z equals 9. Take away 4 from both sides, of course, z is equal to 5. And so my three solutions are y is 3, z is 5, and x is 1.